Okay, so thank you guys for the warm introduction. So today we'll be looking into how to build data pipelines, and our speaker is here with us. And our speaker's name is Duna. Yeah, let me just call the short one. His name is Duna. He's a data engineer, and he has been a friend of the family for a very long time now. I think this is his second section. Is actually taking with us. Okay, this is the second section is taken with us. And the first section was a physical section, and it was mind blowing. And I believe that you guys that are here in this webinar, you guys are going to leave this section filled with knowledge, not just knowledge, practical knowledge, on how to be able to build uh, scalable data pipeline. It's not just about building pipelines; it's about building pipeline that are scalable, pipeline that will be able to pipeline that will be able to stand the test of time. So Duna is a seasoned data engineer and online data engineering instructor with background in computer science and statistics and additional training in AI ML from University of Texas. Duna has also lead tech team in various startups and data pipelines, leveraging Azure, Google Cloud, to drive business insight. Its excellence spans 10 analysis, licenseware, dashboard technologies, and Dover engineering, and Nigeria NLNG. Duna empowers the next generation of data professionals through comprehensive training and real world expertise. So Duna has a very wide range of expertise working with companies and also helping them to build their data infrastructure. So, Saduna, welcome to the course, sir. I think at this point in time, I will have to pass the mic to you, sir.
I'm happy to be here to share my knowledge. First, can you just reply with a thumbs up if you are listening, if you are following? All right, that's great. That's great. Thank you. Thank you. Building scalable data pipelines. So I'm going to take you from basic, I'm going to show you what a basic pipeline looks like, and then the components of maybe an advanced data pipeline, something that is ready for scale. Okay. So, but we need to first understand what data pipelines are. Okay. A data pipeline is simply a series of processes that ingest data from various sources, right? Transform it and deliver it to a destination for analysis, machine learning, or storage. Okay, so we have a source and then we have a destination. Okay, there's a transformation logic in between, right? This transformation logic could just be like data could also include data cleaning for data that is not ready for the use case. Okay, and then there could be data enriching. Okay, we could be like maybe getting data from external sources and adding to the data before taking it to the destination. Okay, so but one major problem I usually like to address when teaching is that the reason for you building a data pipeline is first of all the destination. Okay, so the end defines the purpose and also defines the needs. Okay, so take for example, if your data is just going to be used for analytics, right? Okay, there are certain things you don't need. It's not every field or every part of the data that you have to take to your data warehouse. I don't know if that gives some clarity. Okay, if it's for machine learning, then you know that there are some data points that have to be in the data. So I said that to say that the end goal, that's the destination, defines the purpose, defines the needs of your data pipeline. Okay. Now, and in this session, we are trying to talk about. So we've established the point that the data pipeline is just a series of processes, right? It's just like a pipe, when from the water board to the destination, right? To maybe your house. So there's a place where water is is produced, and then there's a pipe that takes the water, right? Or there's a place where water is actually maybe generated. Yeah, let me just put it like that. And then there's a pipe that a conduit that carries the water, that transports the water from the destination, from the source to the destination, which is your house in this case. Okay. So having established that, we would proceed to talk about why scalability matters. Okay. So yes, please. Someone is raising his hands. Okay. Is there an echo? That echo is likely coming from maybe
No
from let me
echo.
okay. Let me use my USB for um maybe this is let me use my mic. Can you hear me now? Is this better? Okay, fine. So there's a source and there's a destination. And the
Yeah, it sounds better.
yeah, so the destination, which is like the customer that needs the data, okay, determines the pipeline, okay, determines how the pipeline is going to be structured, and even the contents of the data that's going to be needed in the end. So when building a pipeline, go with the concept that you are building for a customer, okay? You are building this data for a customer. The customer might be maybe a BI analyst, that's business intelligence analyst, might be a machine learning engineer, right? Who would in turn, convert the process the data and build a model with it. Okay. So having said that, we are trying to talk about scalability. Of course, you're not going to build a pipeline that is going to be maybe if you aspire to work for a bigger company, your the idea of building a pipeline will not just be for maybe something small, okay, maybe like using pandas or the normal tools that you for the in the normal tutorials you see online. Okay, you are going to think of growth, you're going to think um, of the future. Okay, so I discovered, mostly people just build data pipelines using minor tools, and then when scale comes for a company, the company begins to struggle. Okay, so scalability matters because data grows. Remember, we're talking about big data. We're talking about data in terabytes, in petabytes. Okay, you can't build. You have to build such systems with care and caution. Okay, so scalability matters because data grows, and then also performance. Performance as data grows and the complexity of the data increases, right? You will need to improve the performance. You will need to ensure that your data pipeline is performing very well. Okay, and also reliability. In the reliability, talking about the the ability of your pipeline to be able to handle failures and recover gracefully. Okay, so take for example things like retry logic, things like circuit breakers, introducing things like DLQs that you know will be able to help you, right? Help your pipeline recover in case of failures. Okay, so these three reasons are why scalability matters. Okay, so when building a scalable pipeline, you have to put these three things in consideration. I'm going to show you the principles of building a scalable pipeline. Okay, on what foundation should you build your pipelines? If you have scalability in mind. Okay, so we're just going to proceed to that, and okay, so let me first talk about the core concepts of data pipelines. Okay, of course, you have the ingestion, which is getting data from, like I described in the previous slide, like take for example, getting water from the water board, right, where water is processed, right. Then there's a transformation part of it, which is like your pipe, the pipe that connects from the water board to your house. Okay, so the storage, that's data persistence, be it data warehouse, be it data lake, whatever form. right? Whatever the case may be, it's the destination where the data is going to. Okay, so this is the basic concept. This is the basic, like an ETL kind of concept of data pipeline. So this is extract, that is where data is gotten from, that's ingested, and then there's a transformation logic which involves the processing. The processing might be cleaning, enrichment, and maybe padding, as the case may be, and then the storage. Okay, and there's also, so going down to the ingestion. Ingestion could be in various um, formats, right? So take, for example, for batch ingestion, we could have things like CSV files. Okay, I've worked in a company before, like a startup, where most of our pipelines are most of our data rather, our ingestion is CSV. Okay, so there are companies who still do that. There's also SQL DOMs. Okay, so and then there's also API data. Okay, so these are some of the sources for ingestion. For streaming, of course, you would think of using things like Apache Flink or Kafka or Kinesis, Amazon Kinesis. All right. Yeah, please.
Sorry, like with your experience so far, what's the
Yeah.
most commonly is it ingested form of data?
Okay, so with my experience so far, I've used APIs. Okay, I've used APIs a lot, and what I would say for so this is how it works. Some companies, right? Some companies prefer, instead of communicating directly with the database, for ingestion, they prefer building an API, right? To get to fetch to communicate with their database. All right. This is done in such a way just to avoid kind of complications, because there are times when data is read, because there are times when companies, let me put it in this way, there are times when companies, the same database they use for transactions is the same database they use to for extracting data to fuse into their data pipeline. Okay, so there are techniques in which you can use to actually, instead of just getting the data directly, you create an API, and then you control the logic from there. Okay. So, but may I? Someone wrote a suggestion which I
Okay,
feel is
yeah.
okay.
So,
So
Duna,
let's
yeah,
wait till the
that's
end of the
okay.
session. All right.
Yes. So, to the end of the section, we take questions. So, please, guys, if you
Yeah.
have questions, you can simply write down your questions so that you don't forget. So, once we get to the end of this section, then we open it up for questions. So, you can ask as many questions as you want to ask, please.
All right.
Yeah.
Sorry,
Thank you,
that
Stephen, for the
actually broke my
suggestion.
line of thought.
Yeah.
Yeah, that broke my line of thought. But let's proceed. Okay. So time for questions is coming. Okay. So let's just wait for that. Okay. So there's a transformation part, and then there's also a storage. Okay, which okay, so I've also worked for another company where their database, right, they are kind of the destination for their data, right? Especially this startup that used CSV files for they extract data from CSV files, text files, and PDFs, right? The destination of the data was going to databases, was a database, MongoDB to be precise. Okay, so some companies actually that's their flow, maybe from CSV files or text files or unstructured data, right? Basically unstructured files, right, to a database. Okay, so we used, in such a case, we're using regular expressions, we're using pandas, we're using a lot of things just to extract information from CSV files. Okay, there are also companies that use SQL DOMs. There's also API data, right? like I said. There's also this part of the streaming, which that's what introduces Kafka. That's what brings Kafka. There's also Azure, real-time processing. There's also that of Databricks, okay, both on Azure, okay. And then there's also for the transformation part, there's a cleaning, and then there's an enrichment. Enrichment could be, let's say, take for example, you are fetching data from maybe, let's say, open weather map API, right? So you could decide to enrich the data, let's say with the current population, right? Maybe your data has to do with both the people, right? The demography of the people, right? And the weather information. So you might need to pipe or plug into another, maybe an API or endpoint to get the data of the population to infuse into your data. So that's where data enrichment comes in, okay? And then you also have the storage part, which, like I said, could be MongoDB, could be Postgres, could be a data warehouse, be it, could also be a data lake, okay? And then the other part of it is orchestration, right? Orchestration simply means kind of money, the kind of it's a kind of control over your workflow, okay? So you can maybe take, for example, you can say that your pipeline will run maybe once in every 24 hours, okay? Or every 30 minutes. You can set it like that. So such tools that can be used in this orchestration are maybe Airflow or Prefect. Or there's also ADF, that's that's Azure Data Factory, okay? You can set orchestrations from there, all right? So going on from here, we're still talking about the basic pipeline architecture. So now let's take an example for this open data, that's a weather data pipeline. So this simply extracts data from, if you can see from the code, this extracts data from the open weather map API, right? And then transforms it and then loads it into Postgres, okay? And then there's also the visualization part, which is majorly maybe your end users. That's the maybe the business intelligence analyst, or maybe the data analyst, or data scientist, or machine learning engineer. Okay, so this pipeline, if let me try and zoom in the code, so I will just show you the basic how it looks like. Let me expand this, please. Permit me. Okay, so I just did a sample. It's just a sample code, right? All right, good. I believe you can see this. Okay, so this is a very basic kind of this is a very basic pipeline, okay, which has to do with getting data from Open Weather Map API, right, for a particular city, okay, processing the data, transforming the data using pandas, okay. You can see the logic here. This is the ETL. You first extract using the request, that's the normal Python request. You transform it, okay. Transformation could just, the processing could just be like you just get the city, you get the temperature, you get the weather, the mean weather condition, and then you also get the timestamp, okay. And then you just communicate with your database using encyclopedia and save it, okay. And then you orchestrate it, okay, to start at this time, 2025 today, right? And then it should run hourly. So this pipeline only runs hourly. It runs hourly. So every hour it fetches the latest weather condition of London, okay, and then saves it into the database, okay. So so that's a basic pipeline, okay. What are the tools used here? I just used Python, Airflow, right? Which is this DAG here in the code. And then I also use Postgres, which is my sink. That's where I save the data. And then there's no Power BI here, but I mean, hypothetically, right? Power BI is meant to be used for visualization. Maybe after some time, you could see the time series map, okay, or the change in weather condition, over some time, or even the temperature over a period of time. Maybe let's say if this pipeline runs for, let's say, 5 hours or so, you can use the timestamp to check the progression of the weather. All right. So moving on, we'll go to the principles of scalability. Now, talking about scalability, this is where I think this forms the central part of our discussion. Okay, talking about scalability, you have to think of these 6 concepts: decoupling, parallelism, incremental, containerization, reliability. Sorry, 5 concepts. Sorry. Okay, so now let me talk about decoupling. You see, you when building your pipeline, right? Now look at this. I want you to take a look at this former code. This the other logic, right? The loading logic away from from the you have to decouple them. You have to separate them from each other. Okay, so let's say this is your ingestion. You get data from, let's say, your Postgres. Okay, you get data from Postgres. Okay, this logic, you have to separate it, okay, from, let's say, your transformation. Sorry, let me just do this and then call this transformation. Okay, let's say we are using Spark here. Okay, let's say we are using, oh man, let's say Spark. Okay, there's no Spark. Let's use Databricks. Okay, and then there's also the loading, right? Let's say loading. Let's say you are loading it to let's use Redshift. No, Redshift. Okay. 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 And then you have your orchestration here, which is Airflow. Okay. Okay. Apache Airflow. Okay. Let's just use this, okay, as our orchestration tool. Okay. So, so you have to have them in a separate folder. Okay. Let's say you have your ingestion logic, you have your transformation logic, and then you have your loading logic, right? You separate them here, and then you import them into, maybe you just import them where your DAG lies. Okay, let me send to back. Okay, so all you need to do is here, you import the ingestion logic. Okay, then you also import transformation logic. Transformation logic, and then you also import the loading logic. Okay, and then so after doing this, all you need to do in your orchestration tool, okay, is to call the ingestion, because the ingestion would supply the input for the transformation, and then
you call your loading logic. Okay, so this is an example of a decoupled system. Okay, if I'm just trying to use a diagram to explain it, so take this as different folders. Okay, this is a different folder, or this is a different file, this is a different file, this is a different file in your VS Code. Okay, in VS Code that will be something like this. Let me create a new window, and let me create a new window and do this. Okay, and create a new file. No, let me just open a new folder. Okay, all right, so let me just create a simple folder here. Data, let me just call it data, and open it. Okay, so part of decoupling could look like this. So you have your like, this is a pipeline. Let's say you have your pipeline here. Okay, you have your let's say extract logic. You also have another folder called loading, or better still, let's just use one. Please permit me. Okay, let's use one. So there's extract. Okay, .py. There's transform .py, and then there's a load .py. Okay, so this handles your, this extract handles your extraction logic. Okay, def, and let's see, def ext. Okay, pass, sorry. Okay, something like this. Def load. Okay, and then def transform. Okay, and then let's say this is your, let's say this is your flow dag. Okay, .py. Okay, all you need to do is to import def, let's import def. Okay, okay, you can import, you can just say from extract, import extract ext from load, sorry, from load, import load, and then from transform, import transform. Okay, and then, you know, after defining your dag and the rest, all you need to do is to call the extract. Okay, load and transform. Okay, I don't know if this is fine. This is a basic, sorry, extract transform. This is a basic implementation. Okay, it's just pretty much basic. Okay, so you define your dag. You can say dag equals to this. Okay, and so if you notice this, this is a bit decoupled, right? I have my load in a separate file, I have my extraction in a different file, I also have my transformation in a different file. Okay, one of the previous slides, one of the reasons why we have to scale our data pipelines is that data will grow. Okay, so let's say at the start of the company, you are processing your data using pandas, but data gets to grow in the sense that maybe you get to be processing things like maybe terabytes of data, even gigabytes of data, right? Pandas might not be so optimal in running it. So you might have to use Spark, which is what I'm more familiar with. So Spark kind of runs this distributed data processing, right? So it distributes your workload to different workers. Okay. So for parallel processing, Spark is very useful. I don't know much about DAX, okay, but I'm very sure. But I'm conversant with Spark more. It handles distributed data processing efficiently, whereby your data your workload is you know transferred to different workers. Okay, so just take these as different offices, right? So there's an office working on part of the data. There's also an office working on part of the data. There's also another office working on parts of the data. Then at the end, they compile into a single file. Okay. Also, uh, it gets to a point where instead of batching all your data, like there's a way to incrementally process your data. That's the third concept. Now, this you can do through either watermarking your data. Watermarking your data meaning you are marking the data that has been processed, or you are also taking note of late data. This is most especially done in real-time processing. Okay, so you watermark your data, or you use change data capture for batch processing. So how the change data capture works is that you take note of data you have not processed, or changes from the database, from the source database. So whenever you notice a change, or you either periodically change it, check the changes and compare with the data in your warehouse, or you use the database transaction log. Okay, so there are different types of logging. Um, there are different types of ways to handle CDC, that's change data capture. Another way is also to think of containerizing your data pipeline. The previous one was not containerized. You can containerize using Docker or Kubernetes. Okay, so but the containerization helps you to, you know, it helps you transport your kind of for it helps you transport your it's kind of like your machine, right? You put it in a container so that it can be run everywhere. Okay, so take for example for Docker, in this case, when you containerize your pipeline with Docker, right, you can run it both on Windows, on Linux, and even on Mac. On that's on iOS. Sorry, on MacBook. Yeah, on Mac OS. So it can run across different platforms once it's containerized. Okay, so you don't have to deal with dependencies. You don't have to deal with other dependencies that are needed. Everything is within a container. So, and also the last would be reliability. Your data pipeline has to be reliable. Like I said before, you need to have a retry logic, okay, such that, let's say, if your loading fails or your transformation fails, okay, you should be able to retry. You should set it in a way that it should retry. Okay, you can also simply do that in your orchestration tool, like in DAG. Like take for example the example we had before. Let me go back to this. Okay, there's a way you can introduce a retry here. Okay, in your DAG. So in your orchestration tool, you can put you can introduce a retry, okay, inside this DAG, such that after it fails, it can also retry maybe a number of times. Maybe you can give it like 5 times or 6 times. Okay, so you can also use a circuit breaker. What does a circuit breaker do? It actually, the function of a circuit breaker is to actually check the circuit breaker actually stops running a process after a certain number of, let's say, failures. Okay, so let's say you are retrying, maybe you try to load the data maybe 5 times. Okay, and all those 5 times is not, it didn't go through, it failed. This circuit breaker should be able to stop it. Okay, and say, okay, this failed so number of times, so there's no need to continue. Okay, also there's this deadline queue, right? This dead queue where you use to hide your, I'm sorry, not hide, but you use it to kind of save data that has failed. Okay, sorry, maybe processes that have failed, you log them and save them somewhere. All right, so that's it about the DLQ. So scalability, scaling in action, you know, take for example this parallelism, right? You have different workers. Take for example this, you might, at a point you might just be running your pipeline on one server. Okay, but as data grows, you might need to increase. If it's on AWS, you might need to increase your number of instances and the rest. Okay, that's server 1, server 2, server 3, so it's running on more than one instance of a server. So that's scale, that's one part of that has to do with compute. Okay, so there are other advanced techniques, okay, which especially when dealing with streaming pipelines. Okay, you would have to introduce Kafka, to just like we had it here, producer and consumer. So Kafka works like this. So you might have to introduce Kafka. So Kafka collects data from your source and then keeps it, and then your Spark now reads it in batches. Okay. There's also you can also use Apache Flink, right? In Apache Flink is purpose built for streaming data pipelines. Sorry, data. So Kafka, the how Apache Flink differs from Kafka is that Kafka does, there's this micro batching that Kafka does. So it introduces some kind of latency, right,
Yeah,
into your real-time data pipelines. So when considering scalability, I think it's even better to use Apache Flink, in my own opinion, than to use just Spark. Okay. Secondly, there's also monitoring. So it's expedient to monitor your data pipeline for reliability purposes. Okay, so that everything is like being seen. I know of Prometheus very well. Okay, but I also know about this Elasticsearch kind of stack. Okay, where you have a log. Hello, sorry, there's a noise in the background. Hello. Okay, please, are we following, guys? All right, thank you. So let's proceed. All right, so we also have data versioning. Okay, so as your pipeline progresses, you might want to keep different versions of your data and even the pipeline. So and there are different tools for that. Okay, you can use Delta Lake. Delta Lake comes with a already a meta store, so that comes by default. You can also use Data Hub or Open Lineage. These are tools that help you keep metadata about your data, okay, such that you can so it helps you in your data versioning. You can revert to a particular version of your data or even your data pipeline, right? When considering data versioning. Okay, there's also the CI/CD pipeline. So, I mean, of course, well, if you are into software engineering, you should be familiar with CI/CD pipelines. This is more of like a way of automating, your testing and deployment, so that you don't have to manually do everything. Okay, so you can do that using GitHub Actions. That's what I'm more familiar with. You can also use DBT Cloud. Okay, it's just something I got from my research. Okay, so for an advanced data architecture, what I just made a simple kind of an overview. Okay, so take for if streaming is involved in your, I mean, if your source system is a streaming platform, right? You might consider using, Flink, sorry, Apache Flink, and then also you do well to version your data. Okay, version your data. Now let me go back to this data versioning. Sometimes model your data model can actually change over time. The schema of your data, your source data can change over time. So this data versioning helps you keep track of these things. These data versioning tools like the Data Hub and Open Lineage, they help you keep track of them. So you do well to, like, for every processing, or maybe from time to time, you save it in the metadata store like Data Hub or the Open Lineage. And then there's the monitoring, which has to do
Okay.
with the
I
Prometheus
can't
stuff.
define like
Okay,
that.
you might want to see how your
Huh?
logs. Okay, you might have to see warnings, errors, and the rest. Okay, and then
I know it's a great answer.
the CI/CD pipeline, of course, which automates
I
your
asked twice.
testing and deployment. Okay, then with that you are good to go. All right. So these are some of the advanced techniques when dealing with streaming pipelines. You use Kafka and Flink, right? Also, when you have to monitor your pipelines, okay, using both alerting and so also, some of these things, right? Uh, Airflow also helps you to kind of like helps to alert you, right? Helps you alert you when your pipeline fails. So you can actually specify your email, or you can specify a notification service, right? That Kafka can that Airflow can communicate with when your data pipeline fails. Okay. Now let's just look at maybe a real world use case or something. Okay. So you have a data pipeline for an online sales, tracking company. Okay. So data is being ingested in real time as as a transaction is made. Okay. So immediately, let's say, take for example a platform like Amazon now. Immediately you purchase something. You know, data is being moved to Kafka. Through the producer. Okay. And then the Spark now is the consumer of the data, okay, which processes it, maybe let's say hourly or so, right? And then the data is being saved in Amazon Redshift, okay. And then of course the orchestration is orchestrated using Airflow, and maybe the Power BI, the BI analyst is using Power BI. So, but let's look at the common challenges, okay, that can come on this pipeline. First is that late data, because this is streaming data. Okay, so data can arrive late, even, let's say, because streaming happens in batches, right? If I go back to this drawing and then try to explain that, let me do this. So data comes in batches. We have the first data, which is like this, comes like this, and let's say, oh my. So data comes in chunks like okay, we have data coming in chunks, and so for every window, right? This data, all of them, they stream into this guy. Okay, so let me highlight these guys and move them a bit further. Okay, so let's say we work with a 5 minute window. This is a 5 minute window. 5 minutes window, right? That comes in for processing, and then another data comes in. This data, okay, this is let's say these ones, they came in within these 5 minutes, but this came in, let's say 5 minutes 15 milliseconds. Okay, so there's a way you have to there's a way you have to like watermark this data, right, such that this data will be processed along with this data. Okay, I'm just trying to break down a very complex process, but this is part of the challenge you might have. Late arrivals of data. So data might arrive late. So with that, you have to do watermarking, which does things like event time watermark with maybe you can give a grace period. Let's say you can give a grace period of maybe, let's say, instead of just a default 5 minute window, you can give a grace period. You can say 5 minutes, okay, plus 5 minutes plus 10 seconds. Okay, so this window now, actually, or you can even say, let's take it halfway, 5 minutes, let's say 30 seconds. So that's the window for late arrivals. So when you give this grace period, this data that is coming a bit later than 5 minutes, okay, will be able to join it with this data in real time and process it. Okay, so this is a common way to handle this kind of problem challenge. Okay, now we can also have scaling issues when it comes to using pandas. Like I said before, we're using pandas before, and take for example now, data volume increases because we are talking about big data, like I said. So we need to move our data processing, okay, from pandas to Spark, which handles distributed processing, which has which can handle 10 times more volume, okay, than the previous pandas, which is majorly used for small scale applications. Okay, and then also when there are real-time needs for your data pipeline, sorry, when there's a real-time need for your data pipeline, you have to introduce Kafka. Okay, you have to introduce Kafka, which handles the producer and consumer mechanism, okay, in your pipeline. Okay, so that will result to your pipeline running faster, of course, because you are now using Spark. Okay, and it will even reduce the latency time because of the combination of both your watermarking and Spark. Okay, and then your data pipeline will be running almost continuously and fast. Okay, and will also reduce your cost in a way because you are using distributed processing. You are not, because you are using Spark, and Spark handles distributed processing. That means it distributes your workload across different nodes, so you are not using more CPU time. Okay, so that would result to a cost reduction. Okay, so this is an example of a real world use case. Okay, so first you handle late arrival of data with watermarking, okay, by giving a grace period. Okay, you handle when your data grows, you have to move to using Spark, which handles distributed data processing, and then when you have real-time needs, you use Kafka. Okay, and then Kafka handles the data to either Spark or Apache Flink, all right, for processing. And then of course you have the orchestration. Okay, you have to think of airflow, right? If your data pipeline is on Azure, you use the Azure Data Factory, and you set an automatic trigger that triggers within a time interval. Okay, so best practices and common pitfalls. Okay, you have to design with tempo testing in mind. Okay, that means you have to design your data pipeline in such a way that operations can be safely repeated. Okay, let's say there's a failure. Let it be in such a way that it can be safely repeated without affecting anything. Okay, so you also have to. It's recommended to use schema validation. Okay, so your like I said in the beginning, there's a source and there's a destination. Okay, you know what your destination schema looks like, your database model, what it looks like. So it is recommended to validate your schema even during testing, right? Before deployment. So validate your schema. Okay, always validate your schema. That's the data, the structure of the data going to the destination. Okay, and then test with production like data. So you have to test, like when you are testing it, you have to test as if you are kind of running a production grade application before deployment. Okay, so test with production, even in terms of volume, in terms of data types, in terms of velocity of how the data comes in terms of even the speed. The velocity is same with the speed at which the data comes in. Then the volume, right? Don't just test with megabytes of data. Test with, if possible, if you can have terabytes of data. Try to test your pipeline before pushing to production. Okay. Another best practice is comprehensive monitoring. Okay. Just like I said, I know of Prometheus, right? You have to log your data. Okay, you have to log your data and be able to visualize the logs. You have to log it, your pipeline, and be able to visualize it, maybe Prometheus or other tools. Okay, and then of course proper error handling, like I said in the beginning in the other slide. There has to be circuit breakers. There also has to be retry logic, such that when it fails, your pipeline should be able to run. A process in your pipeline fails, it should be able to run before proceed to the next step. And then also there's these circuit breakers and DLQs, right? And then you have to document data lineage using those tools like I described before. So it's a good practice. I always fall into this. I don't actually document my data lineage, but it's something myself I have to build and start doing. Okay, so common pitfalls. One of the common pitfalls is hard coding credentials. Okay, take for example, look at this pipeline I made here. This credential is hard coded. So when you find yourself putting your credentials inside your code, right, it's a bad practice. Okay, so you are susceptible to security leakages, and the rest. And then not handling schema changes. Plan for evolution. Don't just assume. Like I said, it's a common pitfall for me. Okay, so always plan to handle schema changes, because schema from from the source majorly changes. So you need to plan for that. You need to plan for schema evolution, and you have to adapt your pipeline, to fit into the changes, to let's say to address the changes. Okay. Now, don't overload single components. Sorry. So part of now part of the things you have to be careful about is having a single point of failure. Okay, where most of your logic, let's say, it's inside a particular let's say a particular function, right, that maybe you load a function with a lot of processes. It's advisable not to do that, so that you don't have a single point of failure. Okay, distribute the load across different functions. Okay, and then don't ignore data quality. That's why at every stage, that's why you have to you have to ensure that you run the schema validation very well, thoroughly, before actually deploying your pipeline. Then lack of proper testing. So testing edge cases is very important. Okay, edge cases whereby data is not available, or something fails along maybe with your destination, with your source pipeline. You have to test some of these edge cases. You have to edge cases could also be that, okay, take for example that pipeline that we're fetching data from openware map API, right? Sometimes the data myself, there might be errors from them, so you have to handle those edge cases. Okay, you have to make your data pipeline resilient. Okay, and of course, the poor resource management. Now, one of the pitfalls I usually find people enter into, like take for example some of my students, is that um, they when they are provisioning, let's say for a cloud data pipeline, maybe you are building on Azure, you let's say you specify, or let's say you are using you are building on Google Cloud, right? So you specify your BigQuery to run maybe in West US, let's say maybe in East US, right? And then you now provision, that's your BigQuery is running in East US, right? And then you now provision your Airflow, or maybe your Apache Beam, right, to run your data flow, rather, to run on a different region, let's say somewhere in Asia, right? There's a way that cross region data transfer will always affect, yeah, will always increase your cost. Okay, so you have to optimize your usage of resources. Okay, that's just a basic example. So 3 things to take away from this. Now, reliability first. Build robust systems that can handle any error, that can handle any inconsistency, that's able to address it, and move smoothly. Okay, and then monitor everything. Don't build blind pipelines, data pipelines. Just ensure that you are able to see your pipeline. Okay, you are able to see what is running. You are able to see the errors. You are able to see you are able to see. You are able to visualize it. You are able to see the logs, right? With that can help in a lot of troubleshooting and even enhancing the data pipeline. Okay, and then always ensure to start simple and evolve as needed. Of course, don't use resources that you are not, your data has not grown to use. Okay, so I always believe I have this kind of way of approaching systems. I approach it in a way that in a in a kind of an agile way, right? I know that systems are meant to change. So first build something simple that can work, right? And make it in such a way that it's able to adapt, to changes. So always start simple. All right. So I just have a number of resources here that can help you. Okay. So that can help you maybe in your data engineering journey. Okay. There's this one that I would love to recommend is this Reddit. Very well, is this Reddit community, because this Reddit data engineering, you can just do r/data engineering. Okay, that's on Google, and it will maybe give you some search results. I recommend that you join. There you'll be able to see a lot of information. Let me just show you a lot of articles on data engineering. So this is it. I'm part of the platform, so I recommend that you join this Reddit community. Okay, talks a lot about data and helps you to, you know, keep track of changes in the data world. Okay. So of course there are also books here. Okay, there are also books uh, like designing data intensive applications. I saw that this is available even on it's available almost everywhere. Designing data intensive applications by Martin Kleber. Okay, there's also streaming systems by Tyler Akidao, and then there's also data engineering cookbook. You know, if you need this data engineering cookbook and data intensive applications, you can just chat me up on LinkedIn. Okay, and then there are also online courses on Coursera and Udemy. Okay, so please just do well to see if this can help you. Okay, all right. So I think that will be all from me. You know, I'll be expecting to get questions from you. All right. I hope this helps you to build amazing data pipelines. You know, so tips: start small and evolve. Okay, and you have to put reliability. So you have to first ensure that your pipeline apologies, please. At what point did you miss? Did you stop hearing from me? Sorry. Hello.
Yeah, you were trying to reiterate the final tips.
Yeah. Thank you. So this is for now. Okay. So always ensure your pipeline is reliable before introducing complexity. Okay. Thank you. Yeah, please go ahead. Elijah, right?
Yes, thank you. Thank you so much for facilitating um, this knowledge and dispensation. I want to first of all comment on your
Right.
presentation slides. They're very wonderful. I mean, it was perfectly done. I don't think I've seen a slide like this before, and it's very wonderful. My main question is this. I want to ask, I know most of these workflows are majorly in the cloud. Most of what you have highlighted, is it possible to run a particular a level on a local machine on a PC without going having to do the cloud thing? Can it be run machine the entire workflow from the beginning to
Okay.
the end?
Yes, sure. So so part of the things I teach my students, right, is that you you can run simple pipelines, right? We do run simple pipelines, just like this. Where is that pipeline in the example in the slide? Uh, am I still sharing my screen? Sorry.
No, you're not sharing your screen.
Okay, let me share again. Yes. So you can actually run this locally, right? You can actually run this locally. You can run Airflow locally on your machine. Okay. This is you can run something like this locally. Okay. All right. So your warehouse could just be, or your data warehouse could just be a Postgres DB. Okay. So I have cases whereby even this we designed a star schema, right, in the Postgres DB, because your data warehouse is majorly like it's like a database. All right. So you can run it on your PC. You can run Airflow on your PC, such that you can say let it run so number of times. So everything, you can set up this thing on your PC. Yeah, you can. So let me not just introduce any other thing. You can run it on your PC. I guess that answers your question, right?
So yes.
Okay. Yeah, please. Who is next? I think Hassan, right? Hello. I think
Sorry,
you are
please
far
can
from
you
your
hear me
mic. Yeah, I can hear you now.
Hassan, if you're
now?
still, we can't hear you properly.
How about now?
Yeah, sure.
Sorry. Thank you for the class. And what I want to ask is this: when you were sharing the slides, you talked about some of the issues, some of the bad practices. They said environment variables, like
Yeah.
environment variables. So, like in what sense is it? Like for instance, let me say, for instance, do you mean declaring those things on inside platform file? So I want to know if that is also a bad practice or that's part of what you mean by being a bad practice. Thank you.
Okay. So what I'm saying is, like, if you check from the slide, right, it's use environment variables instead of hard coding, so that your let's say your credentials, they are referenced. That's what I mean. They are
Okay, oh
referenced.
sorry. I thought
Yeah.
whereby everything you wrote on the red was bad. Alright.
No,
I didn't know
that's
the
what
solution was
don't hard code your credentials. That's what I'm trying to say. Like, take for
okay, alright.
example, yeah, don't hard code it. Let it
I
be
understand now.
referenced from an
Yes,
environment variable. Yeah.
thank you.
Thank you. Yeah, Bashir.
Sorry, I still have a question. Can
Yeah,
I
please go
go
ahead.
ahead? Alright, so this Ari said this is going to be like a workshop, something concerning us. So, do you think at any point we are going to like build a pipeline, or what is it like? What will it be like moving on?
So I think I will leave that question to Harry, right? So Harry, maybe
Yeah. Okay. So it's a series. This is just like an intro to what we've been doing. So this series is going to continue, and over time we'll keep advancing, and also we'll be able to like look into building a real pipeline. So that's just what this workshop is all about.
All right, thank you.
thank you. All right. Bashir. Yeah.
All right. Thank you, Duna, for the presentation. I will agree with Elijah. This presentation is quite insightful. So before I proceed to my question, I don't know if at any point we'll be able to have access to the PowerPoint so that we can go through the informations again. So I have two questions. I don't know if I should ask them one by one or I can ask both together. They are just simple questions. The first one is okay. You talked about Azure and AWS. I just want to know if they fall under batch or streaming ingestion and processing, or we can use them for batching and streaming as well. And the last question is about the key takeaways. You talk about start simple and involve as needed. So that's where my question comes from. At what point will one need Spark instead of, like you said, if your data is growing, there might be a situation whereby pandas might not be able to serve you. So like at what point, based on your experience, that one would definitely need Spark for injection and Kafka for processing. Thank you.
Okay, so let me just start with the last question, right? I would recommend you start learning Spark. you start your pipeline with Spark, right? Because just start with your Spark. All right. I think that's what. But if you're asking at what point, of course, your data, the need for your the need for heavy processing. That's what determines the kind of processing framework you're going to use. Okay. So pandas is good for small data. Okay. But I would also want to say that Spark actually has the pandas data frame engine. Okay, so just use Spark from the get go. All right, but you're welcome to learn pandas. All right, but yeah, that's it for that. And then when you talk about Azure, about whether Azure or AWS can be used for batch or stream process. Well, depending on your use case, right? The platforms can be used for both. Okay, you can set up a batch processing pipeline with Azure. You can also set it with AWS. You can set it with Google Cloud. All right. Again, you can do the same for real time. You can set it for all of them. Okay. So that, like, I know for you can set up real time for a real time data pipeline with Google Cloud. You can set it with Azure. You can also set it with Amazon Kinesis. All right. So I don't know if that answers your question, Bashir.
Yes, thank you
Yeah.
very much for you. I heard about this slide.
Okay. I think that would be because I'm sharing the slide with Harry. I mean, with the team. So I believe they will have a way to get it to you. Right. Yeah. Yeah, Sarah, please.
Yes, good morning. Thank you for your time. Um, I'm very new to cloud computing. I just started with Azure, and basically, I'm in data cleaning, as in changing of columns and all that. So, how do I grow from there to this level? Because it sounds very advanced to me. What do I need to do to really key into as in to get to this level, and how do you help me from there? Thank you.
All right. So sincerely, if I would recommend, I would recommend you getting familiar with these communities that I stated here. Um, okay, just keep yourself around the data world. I believe that's just the data community. Okay, maybe you can maybe start by following this Reddit, or even reading from articles from data engineering Slack, right? Or even in LinkedIn groups. Okay, I'm not in any. I think I'm in one data engineering group on LinkedIn or something. But you can search data engineering, groups and join. That's one way to just keep you around the world, to be able to learn the nomenclature around the data engineering system. Okay, and another way is to the next is to actually just keep on doing live projects. Okay, just keep on doing live projects. That's just the way out. Okay, I don't think these things are even explained here are kind of complex like that. All right. Hello, can you hear me?
Yes, I can hear you.
Yes,
All right.
yeah, we can hear you. So, okay, Sarah, sorry, let me also like put more like let's say an addition to what Duna just said. I don't know which of the course are you currently on data camp?
This camp or the one I am doing?
Okay, like data camp. Are you on data camp? Are you part of our data camp scholarship program?
No.
Oh,
Somebody just sent me this link to
okay.
join this meeting.
Okay, that's fine. I thought maybe you're part of a data camp scholarship program. I would they'll be able to like give you guidelines when based on how our courses are structured. But that's fine. Yeah, don't I can continue. Don't I can continue.
So
Yeah.
how
So
can I join if I want to join?
Okay, so the scholarship program is not open at this point in time. We are not like taking people, but once you start taking people, we will surely put out publicity so that people can apply for the scholarship.
Okay.
Yeah. Okay, so you can continue.
thank you. So Steven, sorry, you can go ahead. Stephen Patrick.
Hello, can you hear me?
Yeah.
Yes. Good morning, sir, and good morning, everybody. First of all, I'd like to thank you for taking the time to take us through the seminar this morning. And I listed some questions on the message board that I'd like to ask. Actually, I'm new to the data science or data analysis, but I came
Hello.
up from uh,
Hello.
Okay, Steve, we can no longer hear you. Can you hear us? Okay, I think you can proceed with the next person. Anza, do you have a
Hamza.
question? I think you can go ahead.
Hello, Hassan Aziz. It's Hassan Aziz. It's not,
Okay.
Yes. Sorry. I have a question for Duna, please. So my question is that as a data engineer, can you also like regard yourself as a backend engineer?
so well, I would say that um, so data engineering is a combination of software engineering, right? And maybe kind of data, your knowledge about data, right? For one, I'm actually I'm also a backend. I do a lot of things, right? But I do backend too, right? So learn software engineering. That's the truth about it. Okay, because you will get to be dealing with databases. Okay, you get to be dealing with data modeling. Okay, and even writing reliable code. All right. So this is not like maybe data analysis where you just use SQL and that's all. All right. I guess that answers your question, right, Hassan?
Yeah, I know that data engineer builds
Yeah.
APIs, and I just want to know that if it is like proper to see yourself as a backend engineer, because sometimes where I currently work, when I told them that I have knowledge of backend engineering because of my data engineering, because I did Django at some point in my life.
Yeah.
So and I said I'm a data engineer. They said I am not really a backend engineer, and that was really so. I felt like is it not proper to be a data engineer and backend engineer?
Yeah, and it also depends on the track record you have built over time for companies to consider you. Okay. And so in as much as building data systems, data pipelines is completely, it's not completely different, there's no complete isolation, but it's not completely different from software engineering. However, building backend systems will require you to um, maybe bend your career towards a certain kind of end, right?
Like take for example, working with building architectures that will support systems, that would support API integration and the rest. Okay, so so it depends on the track record you have built over time. That's what I have to say. Yeah.
All right, thank you. So, as a data engineer, like how did you find it working? I don't know. Ari said you also are a ML engineer and a data scientist, right?
How related?
I mean, Ari said you're also a machine learning engineer.
Okay, so no, I'm not like full time into machine learning, right? It's a course I did with UTLC. Of course, I did some models. I built some models, but it's not something I'm into full time. Yeah,
Okay,
yeah,
all right. Thank you.
yeah. Thank you. So, any other question? As Hassan, your hands are still raised. So maybe okay. So Harry, I don't think there's any other question.
Okay, please, guys, is there any other question? If you have question, yes, you guys are going to have the recorded the
Sorry, I
recording
still have
of
a
this
question.
section.
Sorry, before you go.
Okay,
I'm really,
answer.
really sorry about that.
I
All
can
right.
go ahead. Ask your question.
So my question is that you listed some tools that will help us like become like to build a very good um pipeline. So sometimes I've seen like a lot of tools in data engineering field, like from when I started and to this current time. So I don't know. Sometimes you just get somehow like am I going to learn all these things like about you? You are hearing different tools, the same usability. Like for instance, now you wrote Airflow and Prefect, which they are actually the same thing. They are used for orchestration, and so I don't know how you go around it, learning the perfect one, or you just learn everything. And
So now you don't learn everything. Okay, you don't learn everything, but you learn as a need arises, right? So take for example, you just what do you need to learn? You need to learn what is important for building what is ahead of you, for building what you want to build at the moment. Okay, but however, I would actually recommend that at least know little about some of the tools. Like take for example, what you mentioned, Airflow and Prefect, right? I use Airflow. I don't know much about Prefect. You understand? I don't know much about Prefect. So my conversations is around, if you notice, my conversation is around DAGs, Airflow, right? So um, that's what I suggest. So there are cases where maybe you need to face an interview where Prefect, the company, that's what they are interested in. You just need to maybe sit down and with the tools that are available online, I can learn Prefect within 2 days. You understand? So yeah, so I think that's it. I don't know if that answers your question, Hassan.
so what you're saying is that instead of
Yeah,
learning
everything.
Airflow
Learn
or
what
Prefect,
works.
so
Yeah,
learn like orchestration.
yeah. Exactly. So exactly.
Okay.
So that puts it in a good container. Thank you.
All right.
Yeah,
Thank you so much.
yeah. Okay. So Stephen Patrick still has a question. He's back now, I guess.
Hello.
Ah, he's gone.
Hello. Hello.
Yeah. Okay. Yeah, Stephen.
Yes, please. Sorry, I had issues with my network. So, I listed some questions I would like to ask. I said, I'm actually new to the data environment or the community, and some of the questions I would like to ask, it's something relating to maybe the future in terms of maybe if one is done with the scholarship, because I'm currently on the scholarship on data camp in collaboration with Cedars. So number one question is, can we have the recorded video like this seminar we have right here for this class? and maybe the other series that comes along later on. Then the second question is, I want to know what is the process if someone wants to get a job both in Nigeria and to work remotely abroad for the complete beginner, maybe after going through the data camp course on Cedar. So what is it like? Is it like going through an internship first, or what is the process someone have to go through to maybe become a professional just like you, or how what is your like your storyline in someone who wants to get into data science or data to become a data analyst? Then the third question: how can a newbie improve him or herself after going through data camp course on Cedar? What can we expect when preparing for job interview? So, and the last question is, from your experience as someone who has worked in the field of data analysis and science, what are the processes one can learn in order to advance? Because from what you said, going through the seminar, it's as if you've gone further. You've surpassed learning SQL, you've surpassed learning Power BI, Python, and now you've even surpassed going through Pandas.
All right. So thank you. So first of all, as regards the recording, right? I'm not sure. Maybe Harry can answer to that, right? If this session was recorded, I'm not certain.
Yeah, we are recording this section.
Okay. Thank you. So that answers the first one, right? Now, concerning getting a job, like some of your questions are intertwined together. So I will encapsulate them into maybe an answer. Probably when I'm talking, you find traces of answers to your question. All right. So, as regards you from a newbie perspective, right, to getting into specialty or getting into jobs, right, the pathway I'm recommending is that you simply work on projects. There's this guy. Let me show you this guy. There's this guy. I don't have a YouTube channel on that, but there's a guy. Please, if you are watching the screen, please just see this guy. What's his name? Code with you. Okay. Yeah. Yeah. So see, here's a guy. I recommend his channel. Okay, for you to actually to build yourself. Okay, I recommend his channel because he does live projects. So you're able to see some of these projects that can help you build your portfolio. Okay. And one other way is to actually create a public story of your journey. Okay, make your journey public by like creating posts on about um, let's say data engineering, right, or the things you've learned, right, so that the public is following your story. All right, it's one of the easiest ways to get a job. I remember I did that for because I also work as a mobile engineer at some point. I mean, even now. So one of the things I was doing then was that I would pick Google, that's the Gmail platform, right? The Gmail homepage, right? And then I'll build it with, let's see, if, I'll build my own version of it. And then I'll compare the two screens and post it on LinkedIn, right? So doing this kind of helped me gain, so people were now consulting me. You get it? People are now meeting me for projects. I don't know if you get it. So it's another way to actually create publicity, work on projects, and make noise about it. That's all I have to say for that. I don't know if that answers a lot of your questions. So, and also when doing those projects, Steven, you'll get to realize that you are learning some of those things by default. Okay, I can just simply let me give you a simple workaround. I want to learn something. I want to learn. Just look at. Sorry for that, but let me just go something. Let's say, take for example what Aziz was mentioning. Was a prefect, right? I don't know much about prefect, so I want to learn about prefect. So I would say, give me a data engineering project, right? With that involves uh, prefect, right? And teach me everything I need to do. I'm talking from a beginner's perspective to get it done, right? And are you seeing this? With this, I know what to do, right? It's giving me tips on what to do, right? If you just don't know what to do, this is how to start. I don't know if you get it. So you can do a lot of projects. If you are lacking project ideas, you can actually ask these LLMs, one of these LLMs to help you with. Yeah. Uh, I don't know if that answers your question.
Yes, yes, sir. Thank you for that. And I don't know. It's like there's this information, or will I say, um, something a lot of people actually say, like working remotely. I don't really understand when people say they have a lot of these engineers or maybe IT specialists that work remotely abroad. Like, how do they really get all these things? Is it can a newbie get all that, or how does it really work?
Well, it's possible for a newbie to get a remote job, but mostly internships. Internships, rather. Mostly internships. That's what I would say on that. Okay. Working remotely just simply means you are here and you're working somewhere. Maybe you are, I'm in Jos, but I'm holding this session from Jos, right? And you are in separate places, right? That's a remote conversation, right? So as in terms of definition, it means living somewhere and working elsewhere. That's what it means. And then how to get that is, I mean, it's possible for a newbie rather to get such, and if you follow these steps, I'm telling you to, most likely you'll be able to get one. Okay. One thing is patience and consistency.
Does it also apply to abroad remote work?
Yeah, it does. I've worked abroad too. I've worked as a design engineer for a company in Romania. I also teach for a company right now, Ten Analytics, a Canadian company. Right. So it's a remote work. All right.
Please, sorry to cut you. You talked about perplexity. How do we sign up to perplexity? Because I'm only
Just go
aware
to
of.
perplexity.com, perplexity.ai. Sorry, perplexity.ai. I'll paste the link here. There are many
Okay.
other LLMs. This is just an
Is
example.
this, is this free?
It's free, of course, to some extent. Yeah, it's
Yeah,
free
to some
mostly.
extent.
Yeah. So, Benjamin, your hands are raised. Yeah.
Okay. Good morning, presenter. Apologies, I joined late, but at least I've been following the track of events. So one of the questions I wanted to ask, you've answered it. That's the site for this AI generated learning for data engineering. So my question goes around data scientist. When I looked at the scope of a data scientist, you have a lot of, let's say, some programming languages that you need to learn. Spaces like I wrote for programming, Python, NumPy, and SQL and the likes. So in a real world situation, because we are looking at how to make some things happen within our own space. In a real world situation, what do you think? What program do you think one can confine himself to and specialize to be able to stay afloat in competitive environment as we find out? So that's my question because currently I'm on this scholarship, Cedars and scholarship. I'm doing some stuff, but I just need to get a direction. I picked up a course on data science on the SQL, associate data and associate data scientists in SQL. So I really want to have a direction. That's just my question. If you can help me on that, I'll be so glad. Thank you.
Okay, so I think what I would recommend, right, is not even far fetched from what I recommended to keep because your question is that how can you keep yourself, you know, how can you keep yourself advantaged in this competition, right? If I get your question well.
Yes.
So it's nothing far fetched from what I said to Stephen Patrick, right? It's actually to give attention. It's actually to be consistent and patient while building projects. Build projects and make noise about it. Because nobody is going to come to your PC. Anything you build on your PC still stays in your computer. You understand? Hello. So
Yes,
it's
sir.
at you, yeah. So it's as you now take for example, let me give you an example. This I take this presentation as a project now. This presentation I had to work on. While I'm working on the presentation, I'm seeing lapses from my own side that I need to work on. I don't know if you get it. So
Yes.
approach it with that kind of approach your learning with that kind of mindset that um allow what I would say is allow yourself to grow, right? Allow yourself to grow. It's it's okay if you don't know anything. First of all, when you accept that, then you begin to take steps to learn. Okay? Okay, what is your goal? Your goal is to become a good data scientist
Yes.
that is employable, right?
Yes.
So
Yes.
I just maybe take for example you just go to like perplexity.com and say, okay, see, I want to be a I want to be a very good data scientist. What do you suggest that I do? While you are following that data camp course, okay,
Yes.
you are also helping yourself to, helping yourself with strategy. Okay, of course, the data camp course will teach you skills. Okay, but I recommend that you have a strategy towards your skill. Part of the strategy is what I was telling you. So, because strategy is everything, there are many people, let me tell you of the truth, there are many people who are less skillful and they have a lot of they have a lot of opportunities in their hands.
Mm.
Why? Because of the strategy they apply. So knowledge is not enough. The strategy you employ towards the skill, and part of the strategy is working on projects, making noise about it, so that you're always in front of people to see. You understand? Yeah. I think
Yeah,
Thompson has
yeah.
a
Thompson wants to say something.
yeah.
Yeah, Duna, well done. So I wanted to just add to the what you're answering to. So on the perplexity stuff, the query, the prompt you are adding in, there's a lot of basic to intermediate to advanced resources on data camp. So it's important that while imputing the prompt on perplexity, also you can tell perplexity that you have premium access to data camp that you should outline because perplexity has access to a lot of platforms like live platforms. It can connect to other websites or what other platform pull data. So tell you that you are on what's it called, data camp platform, it should outline this that relates, that has to relate to what you're looking for. To then outline what you need to follow. But first of all, before you do that, it's important that if you're a beginner, that you cover a full should I call it a diploma? Like, for example, is it um, associate data analysis or associate data science, whatever course? Cover that one to give you a foundation first. A lot of the courses stuff we are talking about here are advanced and is mostly narrowed down to those who want to be data engineers. I know some persons are in the group and they are overwhelmed because they are thinking from the standpoint of data analyst. So, Duna, it will also be important to note that it's not composed that data analysts jumped to data engineers simply because this is a
Yeah,
webinar
yeah,
data engineering. If you want to
yeah.
be a data analyst, stick to your path. Maybe over as we progress, we'll have a course for strictly for data analysts, but this is mostly for data engineering. So if you are in the data analyst or data science track, there are some things here that you will learn, sure. But then there are other things that you might want to just take it off your table because it doesn't apply to your use case or to your track. Yeah, that's all I wanted to add.
Thanks so
Okay.
much.
Okay. Thank you, sir. So, please, on this thing, just like Thompson said, on data camp, you have a full track to follow. Okay, you have a full track to follow. So if you're doing data science, there's a full track to follow. Like from Duna's standpoint, based on the things that he has been talking about, he has been doing this for quite a long time now, and he has built capacity while doing this. He has moved from different technologies, different tools. He has learned different tools. So same thing as well for you. Currently now you're taking data analysis with SQL. So when you're done with SQL and you see outline and you're able to like build project with SQL and you know that you're very capable with using SQL to build project, you can decide to add Python to it, add Python to your data science skill set. Then from there, you see you can add other tools as well to your skill set. So that's just how it has been. Just like Duna, he mentioned a couple of tools. All these tools, it did not start one day using all these tools. So it start by from one. It start like let's say for him is a Python. He does data analysis with Python. It start from the basic first. He actually learned the pandas and other this thing that we use for analysis in Python before he move on to and according to him that's the one that he prefers most using. Okay, so that's the same thing as well for you. So as you continue building capacity based on the courses that is actually being aligned there on data camp, you will also get to like know all these things with time and consistency. Yeah. T.
Yeah, so what I want to add is, please, the learning should not be forever. Too much emphasis on learning. Once you finish your intermediate stage, apply for internship. Because some of the things that will determine what or help you know what you should learn next is if you're in the field, like you got an internship, you're working with a particular organization or a team, you now know other things that because there are some things you might just, if you just spend the whole of your life learning different tools, you might end up, for example, you got hired and realize that they don't need the tool. They are doing data engineering, but they don't need a lot of the tools that you are learning. So you just need to learn the major the key tools. Once you build to intermediate level and you're confident enough, please start applying for internship, apply for jobs, apply for opportunities, so that you apply your skill to real life projects along building your personal projects as you learn. If I want to give a real life example, I got in. I'm currently with a team, an organization in Lagos, and when I got there, in fact, my role requires that I discard all my skills in Python, and I have to jump to start learning. And it's not, and then for learning skills, tech, there's no limit. I'm required to do something that I could do before with Python and Django and all that. But right now, what I'm required to use is to use Node.js and Java to do the same thing. So I had to now I have to switch to start learning this. So one of the ways to help us narrow down our track is if as you're learning, pursue opportunities at the same time. It will help you narrow down some stuff, or learn if you want to, let's say for example, you want to work with Google, find out what Google are using, the tools they are using, so you narrow down your learning, so you don't just learn randomly and not really arriving anywhere.
Okay, thank you. Thank you so much. I also want to make a plea. I so much love this section. It's really insightful, exciting, and if we can be holding it at weekends, is even better for some of us, because weekdays is like quite very busy and demanding. So I really commend your selfless innovations to build up capacities. So it's just my humble plea, so that we can really fully concentrate and give full time for it. Thanks so much.
Okay, sir. Please, any other questions? Yeah, Duna, you want to say something?
No, my hands are not raised.
Sorry, I want to. Okay.
Okay, yeah, you can continue, sir.
Yes, I want to ask if we are told that we can start up with an internship opportunity, but we are not getting something like that. How can we, or how can you help us get an internship role, even if it's unpaid, to be able to apply all that we've learned?
Okay. Okay, T, would you take that?
Yeah, so what I wanted to say from
Okay.
our end at the moment, what we really push out there, our job right now is to empower people to build skill. The only way we can help right now is if we see opportunities, we can share the link for you to apply. But personally, you have to push for that yourself. There are internship stuff that are being posted on LinkedIn if you are active, and other platforms that you can follow. You can also search online for internship opportunities for your role, or entry level jobs for your role. But for us, we talk about Cedars now. We do not have anywhere to put you there. Get you in directly for now. But as opportunity comes up, if we see link, we will share to the platform.
Okay. Thank you, sir. Godin, Gideon, your hand is up. Or Duna, if you want to speak, you can simply unmute as well.
No, I don't think I have it.
Good afternoon.
Something to say.
Okay, yeah, Gideon, go ahead.
Hello.
Yes, Gideon, we
All
can
right.
hear you.
Thank you for the lesson thoughts. It's really impacting. Sorry, at the point in time there was no light, so my system went off. So I had to come back in between when the question had started. But I just need a little clarification. What's the basic difference between data engineering? Because I believe the pipeline, the scalability we talked about has to do with data engineering, right? So what's the basic difference between data engineering and data analytics?
Okay.
Hello. Did you get the question?
Yeah. So think of this: a data engineer is a business seller, right? A data analyst is someone who is its customer. A data engineer supplies data for the data analyst to do all the visualization. The querying that he has to do from the basically a data analyst or an analyst fetches data from a data warehouse, fetch data from a data warehouse. Okay, and who is responsible for getting data into the data warehouse is the data engineer. So that's the perfect example I would give explanation.
So that
Right?
means
So
they actually
the
depend on
analyst,
each other.
or rather, the analyst depends on the data engineer. right? But also, so it's interdependence, because if you notice from the beginning of the session, what I said was that what defines the pipeline is knows what he wants, right? So that will determine how you are going to structure the pipeline. If the pipeline is majorly for analysis, then there's a way to go about it. If it's for engineering, if it's for model training, there's a different way to go about it. So of course, the data engineer, maybe for specifications, he will on what is needed on the data pipeline might depend on the analyst, right? For because the job of the analyst is to give business insights, okay, which is not the specialty of the data engineer, okay. I don't know if that explains a lot to you.
Yeah, Gideon, did you get that? Gideon, if you're trying to speak, you're muted.
Yes, sir. It does, sir. Thank you.
All right, you're welcome.
Okay. Okay. Any other question?
Yeah, time is up.
Okay.
Okay.
Yes, I got it, sir.
Okay, that's fine. So I think we have come to the end of this section. But before we leave this call, please can we give a clap to Mr. Duna? Please, can we give an appreciation clap to Mr. Duna? Thank you so much, Mr. Duna. Thank you a million times. We are very, very much grateful for taking out a huge amount of your time. I know that 2 hours is really a long time for somebody to give out.
Thank you,
for
guys.
giving out this particular amount of your time to share your knowledge, your wealth of knowledge with us, with our community. We are really, really grateful. Thank you so much. And for everyone on this call as well, thanks to you as well for making it to this section, for making it what it really is, because without you, this section wouldn't have old, wouldn't have like the one of impact. So thank you so much as well for making it to this section. So please, I want you guys to keep your eyes open for the next sections. So it's not just data engineering sections that will be holding. So we also hold sections for data analysts. We also hold sections as well that has to do with soft skills, things like communication, things like emotional intelligence as well. And let's say by next month as well, we'll also look into holding sections about how to get remote jobs. Okay, so just like Thompson said, at this point in time now, we are into you guys building your capacity, learning, equipping yourself, building capacity. So when you've built capacity now, and we start like talking about how to get those opportunities now, how to be able to get those jobs, you have the capacity already to utilize those opportunities. So at this point in time now is to focus on building those capacities so that when opportunity comes, you'll be able to seize those opportunities and make good use of those opportunities. Okay. So thank you, Duna. Thank you, everyone. I don't know, Thompson, if you had something to say.
No, I'm good.
Okay, so thank you everyone, and keep your eyes open in the community as well. And for those of you who are asking, who are not, who are asking about the scholarship, I just dropped social media links uh, in the chat. You can follow us so that when we post about the scholarship, you can simply get notifications for the scholarship. And also following us, you'll also be able to like get notification for further webinars that will be coming up as well. Okay. So thank you so much, guys, and see you guys sooner, because we surely see you sooner.
Thank you so
Thank you,
much.
everyone. Bye.
And bye.